In this section, we'll explain how to configure this workflow. Before we officially start, there is some preparatory work to do. We need to first configure several essential initial parameters for the grid strategy in the strategy variables, trading pair settings, maximum grid levels, grid step size, and lot size per trade. These parameters will be used by all subsequent nodes, so they must be configured in advance, especially the step size and grid levels, which directly determine how large your grid range will be. Once configuration is complete, we can start building the nodes. The starting point of the workflow is the client close trigger. I've set it to a 60-second period, meaning it triggers once every minute. Each time it triggers, the entire process starts running. This trigger acts like a heartbeat, beating once per minute, driving all subsequent nodes to work. After triggering, the first thing is to check whether parameters have been initialized. Here I use the function for persistent storage. If the grid data is found to be empty, it means this is the first run, or the strategy has been reset. At this point, a volatility check is performed first, calculating the volatility of the most recent 20 candlesticks. If volatility exceeds 2%, initialization is skipped, and we wait for the market to stabilize. After passing the check, the current price is obtained as the initial price, current equity is obtained as the initial equity, and then grid price arrays for both long and short directions are constructed around this price. Once this step is complete, the grid framework is built. After parameter initialization is complete, we enter the strategy execution node, which is the core part of the entire system. This is where the core logic of the traditional grid strategy resides. The code checks the current price, iterates through all grid levels, and determines whether to trigger open or close position conditions. For example, if the price drops to a certain level's long open price, it opens a long position at market price. If the price rises back to the close price, it closes the long position at market price. Short positions follow the same logic. After each trade, the state is immediately saved to avoid data loss. This part is purely traditional strategy, completely independent of AI. After strategy execution is complete, it is time for the monitoring node to take the stage. After strategy execution, the monitoring node begins to work. It counts how many positions are currently open, how long they've been held, how much the price has deviated from the initial grid, and displays a table in the status bar, including initial price, current price position count, floating profit and loss, and other information. This node determines whether AI analysis needs to be initiated based on previously set trigger conditions, and checks the AI cooldown time to ensure it only triggers once within 10 minutes. After the evaluation is complete, the workflow branches. If the trigger evaluation returns false, it proves the traditional strategy is running normally, and the workflow enters the no operation node. This round ends, waiting for the next line trigger. But if it returns true, it means an anomaly has occurred, and the AI analysis workflow is entered. First, MCP's new sentiment interface is called to fetch recent market news and sentiment scores. Then through the result organization node, news data and position status data are integrated together and fed to the AI sentiment analysis node. The AI comprehensively analyzes this information, determines whether the current situation requires grid adjustment, and returns a clear yes or no. After obtaining the AI's judgment result, the final step is executed. If the AI returns yes, it proves that strategy parameters need to be reset, so we enter the reset strategy node. This node will close all positions for stop loss, clear grid and init data, and record the current time as last day time. When the next cycle's client triggers because the initial data is empty, strategy parameters will be reinitialized, essentially restarting the grid with the new price. If the AI returns no, then only last day time is recorded, entering the cooldown period, and the strategy continues running with original parameters. The advantage of this design is that the AI isn't just guessing blindly, it knows how the strategy operates, can see the current position status, and can read market news. With complete information, judgment is more accurate. Alright, that is the entire workflow construction process.